This is Geometry, Unit 8, Day 4. We're writing equations of circles. We're going to first start with talking about the equation of a line. Y equals mx plus b. That was the equation of a line you learned in Algebra 1. The m represented your slope. The b represented the y-intercept. So when you have an equation of a line, we're used to having an x and a y. Now this is standard form of a line. This is slope-intercept form. Two different formats. Well, similar to the equation of a circle, we need to know what variables stand for. We need to be sure we understand where the center is located and also what the radius of our circle is going to be. When we know the center and we know the radius, then we can write the equation of a line. The equation of the line is the radius squared equals x minus h squared plus y minus k squared, where the h and the k are the center of the circle and the r is the radius. So if we come over to the circle, we have a center at 0, 0 and a radius of 4. So using our equation, x minus h squared plus y minus k squared, the h and k for the center of our circle will go into our equation, and the radius being squared will go in for the r. So 16, x minus 0 squared is just x squared, y minus 0 squared is just y squared. We leave our equation in the format of the x squared and y squared being on one side of an equal sign. We don't have to solve for the y. You don't have to get y by itself. Our second graph, we have a center point at a different location. We're 2 over and 1 up. So the center is at 2, 1. That is your h and k. The radius is 4. So if the radius is 4, we take our original equation, we plug 4 in for the radius, our h value is 2, and our y value is 1. So we would write that as 16 x minus 2 squared plus y minus 1 squared. You do not distribute the 2 through. You do not call it x squared plus 4 or x squared minus 4 or anything like that. That's not how you handle a binomial with a power. On the other side, we have a center, which is your hk, and a radius of 6. So if your hk are both 0, then you take your standard equation and you plug in 0 for your h and k, 6 in for your r, so 6 squared is 36, x minus 0 squared is x squared, then y squared. Whenever you have a center at the origin, it's just going to be x squared plus y squared. If your center has moved and it's no longer at 0, 0, then that's when you're going to have parentheses. So here we have a center, h and k, with the radius of 2. So we take our equation and plug the 2 in for the r, x minus the negative 5, so notice we have to put the negative 5 in parentheses, and y minus the k, which is a positive 2. So that comes out to be 4, x plus 5 quantity squared, and y minus 2 quantity squared. Next we have our h and k, which is 0, negative 3, and a diameter of 10. If the diameter is 10, then the radius would be 5. So we'll start with our equation. R squared equals x minus h squared plus y minus k squared. So our equation of our circle, we plug in our h and k. The k value is a negative 3, so you minus a negative 3. And your radius was 5, so 5 squared. Always be sure to identify what information they're giving you. In this case it was a diameter, and we turned it into a radius. So we have x squared plus y plus 3 quantity squared. Right in the equation of a circle, here we have the graph. We notice the center is at the origin. So that's the HK. The radius is 3. So to write the equation, we're going to say x minus 0 squared plus y minus 0 squared equals our r squared, which is 3 squared. X minus 0 squared is x squared. Then y squared equals 9. Remember, if the origin has the center, then your equation will not have parentheses. It doesn't have an x and y value. This centers at 4, 3. So that's your h and k. The radius is 2. So x minus your h value, quantity squared, plus y minus 3, quantity squared, equals 2 squared. Notice I've put the r squared on the right side of the equation. It doesn't matter if it's on the right or the left. It can show up on either side. So your final answer is x minus 4 squared plus y minus 3 quantity squared equals 4. Center point is 1 over 1 down with a radius of 5. So x minus 1 quantity squared plus y minus a negative 1. Notice how I used parentheses for the negative, equals 5 squared. X minus 1 quantity squared plus y plus 1. Two negatives make a positive. Quantity squared equals 25. So we have our equation. Since the center is not at the origin, we see that we're using parentheses. Because one of the coordinates is negative, we're going to have a plus. What's inside the parentheses is always opposite of the way it looks for the coordinate. It's a positive 1, in your equation it's going to look like a negative 1. because the equation itself is x minus h. So we could talk about if circles are congruent. Are all circles congruent? Are the previous three considered to be congruent? And the answer clearly is no. They're not the same size. Some are bigger than the others. So we would say that the radius is different. The radius has different sizes. Are the circles considered to be similar to each other? If you notice, not all triangles are similar to each other. They have to have some characteristics that make them similar. The angles have to be the same, the sides have to be proportional. For a circle, all circles are considered similar, so yes. Because all circles are growing at the same rate. The radius helps define the scale factor. So if they're similar, we should be able to calculate a scale factor. So what we're going to do to try to identify our scale factor, let's prove that the above triangles are similar by comparing the ratio of the circumference to the diameter. So we're going to make a ratio, which is a fraction, of each of their circumference over each of their diameter. So the first circle here was considered circle A, circle B, and this would be for circle C. So for the A question, what was the radius? We counted 3, so that would make the diameter twice that amount. And the circumference is 2 pi r. Another way to write circumference is diameter times pi, so 6 pi. For question B, the radius is 2. If the radius is 2, we know that the diameter is 4. In circumference, that's known as diameter times pi. For question C, the radius is 5. So that makes the diameter 10 and the circumference 10 pi. So we want to see if we can get a common ratio to come up every time. So what we're going to do is make that ratio, that fraction, of the circumference over the diameter. If we take our first example, 6 pi divided by 6, and we reduce what we can, you see that you get your pi. That by itself doesn't mean a lot. But if we take another circle, its circumference divided by its diameter, and reduce what we can, we're also getting pi. And that's going to stand in any situation. The circumference, in this case 10 pi, divided by its diameter, is going to be reduced into pi. So no matter what circle you use, the circumference divided by the diameter is always going to give you the same term. In this case, it's pi. The circles are all similar because the ratio of of the circumference to the diameter is pi. Our last page, we're going to be translating one circle on top of another. Then we're going to look at the dilation that's going to make the circle grow or shrink to match the image. So first, the D tells you that that is your original. That's called your pre-image. And then your D prime, that's your new shape or your image. So from D is where we're starting. That tells us that we need to move to the right, and then we need to move up to get over to D prime. We're not going left and down because we have to start with just the D, not the letter with the dash above it. So when we're moving over, we see that we're sliding over 5 units, and we're moving up 7 units. So there's a translation, which is a slide. Translation 5 units right and 7 units up. The rule that we can write for a translation, we start with the original points, x and y, whichever points they happen to be, and you're going to translate each of them x plus 5, meaning taking every x value and adding 5 to it. That would slide every circle to the right. And then we're going to take all the y values and add 7 to them. That would translate your circle with the same radius, same diameter for that matter, but same radius over here to the origin. But now we want to look at the scale factor to what would make it grow and become bigger so it matches the same size. So remember, to determine what a scale factor is, we look at the image over the original. And the common part for circles to look at is their radius. So we're going to look at the radius of our image. Which shape again was considered the image? The D prime is your image, whichever symbol has the prime to it. So we look at that and we see that the radius is 5. And the original, without the prime, has a radius of 3. So the scale factor is 5/3. Let's try that one more time. We're going to start with the original shape. Which one here is considered to be the original? Of course, the P is your original, and P prime is your image. That's where it's going to go to. So we notice that we're going to slide to the left, then we're going to slide up to get to P prime. We go to the left 8 units, and we go up 9 units. So we're going to translate left 8 units and up 9 units. So our rule that we'll use is x minus 8 because it's to the left, and y plus 9 because it's going up. The scale factor, remember, is image over original. The image, which circle is considered our image? It's the P prime is your image, so it has a scale factor of 2. The original does not have the little tick mark above the letter, so it's just the P. It has a radius of 6, and that can be reduced down to 1/3.